Hello and howdy, ladies and gentlemen. Root Beer here, looking at question 16 on our 2010 Fermat paper. Positive integers a and b satisfy ab equals 2010, so I'll have to start thinking about the factors of 2010. It's always a good idea to know things like the factors of the current year. When you're writing contests like these, people like using the current year. Factors are good, whether or not it's a prime or a square. These are important things to know, and they can work their way into questions. If a is greater than b, the smallest possible value of a minus b is. Okay. So, we can just go through this question and say something to the effect of, well, there aren't that many factors of 2010, so we could list them all out and take their differences, and that would be fine. Okay? And I might end up doing that, but if we stop and do a little reasoning here, we want the smallest possible value of a minus b. How do I make a difference as small as possible? Well, if the numbers are as close together. So I want the factors of 2010 that are as close together as possible. So if I start listing out the factors of 2010, I want the ones that are really close together, the closest pair that multiply to 2010. And there's something that can sort of help us out a little bit with that. These numbers are also going to be the closest factors to the square root of 2010, which is about 44.8. So those are the sorts of numbers I'm going to be on the hunt for. But we need to start listing out the factors of 2010. Okay? So, just to say, what could we have here? Is there a fast way to do this? I guess maybe going with primes. So 20... There we go. Maybe just say, well, I can definitely get a factor of 2 out of there, and that'll be 1005, so I can get a factor of 5 out of there. And that'll be 201, and I can get a factor of 3 out of that. 18 gives me a 6, and then that leaves a 2 left over, so 67, and 67 is a prime. So I get 2010 is 2 times 3 times 5 times 67. Oh, so that's kind of nice. It's a square-free number, which is pretty nifty. Okay, now I can start listing out factorizations of this pretty quickly by picking pairs of numbers or single numbers and saying you're in the count, you're not. Now, this 67 immediately draws my eye. I don't want it to pair up with 2 or 3 or anything like that. I don't want to say 2 times 67 and ask what's the other factor, because these other numbers are so small they're not even going to come close. So I want to leave 67 on its own. So I'm looking for 67 times, well, what's left over here? 30. So the closest we can get is 67 minus 30 is 37. Now, if you're not quite confident in that reasoning, and I think I saw this as answer A. Let's say it's A. Yeah, A. Okay. Now, A happens to be the second lowest. 1 is the only other one. I'm fairly certain that we can't get a 1 here. But if you want to, write out more of the factors. You don't have to make the big chart that I sort of alluded to. You can if you want to. But you can write out all the factors. I'll probably write them out in order, and then ones on the very outside pair up, and so on. And we just want the pair in the middle. But you can get 2, 1005. You can get 3. 2010 divided by 3 is 670. So those guys are together. 2010 divided by 5 is 402. You'll notice they're getting closer, and if you wanted to make their differences, you can actually start making them. The next one would be 6, and so 6 is 2010. Just grabbing my calculator to make this faster, because I have technically answered the question, but I'm adding in additional information for people who might be a little uncomfortable with the logical leap I made there. No 7... No 8, no 9, there's a 10, 201 here. No 11, no 12, no 13, no 14, there's 15. And I realize these numbers are starting to get super crammed together. So 15 pairs with, let's start writing these a little lower. 15 pairs with 2 times 67, which is 134. And then you can get, well, I think the next one after that is just going to be 30 and 67. And that's it. Now, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 pairs. And I know that's it. I know I haven't missed anything. And the reason I know this, if you have a number who's listed in terms of primes to exponents, so in this case 2 to the 1, 3 to the 1, 5 to the 1, 67 to the 1, but in general P1, because I don't know the first prime, to some power E1, and P2 to the E2, and so on, the number of factors of n is E1 plus 1 times E2 plus 1 all the way times EK plus 1. So in this case, it'd be 1 plus 1 times 1 plus 1 times 1 plus 1 times 1. So 2 times 2 times 2 times 2, 2 times itself 4 times, and that is 16. So that's how I know I've got all the factors there. And you can take this information and make a big old chart, but thanks to our reasoning, we know we just need the two that are closest together. Okay? So I think I've taken more than enough time for that question. It was certainly over fairly quickly, and our answer is going to be A. So up next, question number 17. Feel free to have a look at that, and I will see you in the next video for that one.